Good morning, everyone. Welcome to Elite's Master Plan 20. In this series, we will be solving 5 important MCQs. And today, we'll solve 5 MCQs on physical pharmacy. These are the questions from previous year GPAT papers. So now, let's start with today's session. Question number 1. Which one of the following does not afford a macromolecular inclusion compound? Options are zeolites, dextrins, silica gels, cyclodextrins. This was a question from GPAT 2011. तो क्वेश्चन में ये पूछा है कि कौन सा ऑप्शन है जो हमें मैक्रोमोलिकुलर इंक्लूजन कंपाउंड नहीं देगा. Okay, so what is macromolecular inclusion compound? It is coming under a major class called as complexes. Okay, complexes constitute a separate class of compounds which results from some type of interactions among different chemical species. Okay, और ये जो interactions है वो हाइड्रोजन बॉन्डिंग हो सकते हैं या फिर वैन डर वाल्स फोर्सेस, डाइपोल डाइपोल इंटरेक्शन, कोऑर्डिनेशन बॉन्ड्स, कोवैलेंट बॉन्ड्स. Okay, so various types of interactions are involved in this case. Then these complexes possess some properties which are different from their individual components. Okay, and these properties are solubility, light absorption, partitioning behavior. Okay, and hence we can see that complexes are very important in our pharmaceutical industries. Okay, they have many applications. So now coming to the options, zeolites, it is a macromolecular inclusion complex. Dextrin is also an macromolecular inclusion complex. Silica gel is also an macromolecular inclusion complex, but cyclodextrin is monomolecular inclusion complex. Okay, so the correct option over here is cyclodextrin. Now to get a better idea about this, we'll see the classification of complexes. तो क्लासिफिकेशन में फर्स्ट है मेटल आयन कॉम्प्लेक्सेस. तो हमें नाम से पता चलता है कि मेटल आयन यानी यहाँ पर एक सेंट्रल एटॉम प्रेजेंट होगा. करेक्ट. सो फर्स्ट वन इज इनऑर्गेनिक टाइप. उसमें एग्जांपल है हेक्साअमाइन कोबाल्ट 3 क्लोराइड. तो ये जो कोबाल्ट है दिस इज एक्टिंग एज अ मेटल आयन और अ सेंट्रल एटॉम, एंड दिस NH3 ग्रुप्स व्हिच आर देयर they donate their electrons to this cobalt ion. Okay, and they act as a ligands. So whatever is there inside this bracket is called as coordination sphere, and whatever is there outside the bracket is called as ionization sphere. Next one we have chelates. So in chelates the example is EDTA. Okay, so this is an example. This is a structure of EDTA, ethylene diamine tetraacetic acid. Okay, and this chelates and inorganic types, they have a basic difference. In inorganic types, we can see that the ligands which are there, they will give only one pair of electrons. That means they are unidentate. They will have only one point of attachment to the central atom. But in case of chelates, they have a more than one point of attachment. In this case, EDTA has 6 point of attachment and hence it is a hexadentate. Okay, तो यहाँ पर 6 points of attachment है, लेकिन inorganic types में there is only 1 point of attachment. Okay, and one more thing you have to remember is that coordination number of central atom. Coordination number is the maximum number of atoms or groups that can bind to the central atom. Okay, or the metal ion. Next one we have olefin types. Under olefin types we have silver olefin complex. Then we have aromatic type. Under that we have pi bond type. Example is toluene and HCl. Sigma bond type complex. Example is toluene plus HCl AlCl3. And then we have sandwich type. That is example is ferrocene. So these two types, that is olefin types and aromatic types, ये जो दो types है वो majorly as a catalyst act करते हैं. Okay, they are used in the formation of drug products, intermediates, etc. Now next, organic molecular complexes. तो organic molecular complexes यानी इनके बीच में जो bonds होंगे वो weaker bonds होंगे या फिर hydrogen bonds होंगे. Okay, between these organic molecules. So first one is drug and caffeine complex. So we can see the example over here. caffeine and benzocaine. Okay, so caffeine, the one, this nitrogen which is there at one position, okay, this is acting as an interacting center. Okay, this is slightly electropositive, and in benzocaine we have a carbonyl group which is also polarized, and that's why this oxygen is getting slightly negative charge. And this nitrogen at one position and benzocaine's carbonyl group is acting as a interacting centers, okay, of caffeine and benzocaine respectively. So this is one type. Another example is PVP and tannic acid or polyacritic acid. Okay, then we have queen hydrone complex. Okay, so in queen hydrone complex, we can see that this is a hydroquinone, which is electron rich, and benzoquinone, which is electron deficient. Okay, and here the overlap of pi bond is taking place, plus there are hydrogen bonds which stabilizes this complex. Okay, and last one we have picric acid type. Okay, और यहाँ पर एग्जाम्पल है ब्यूटेसिन पिक्रेट टाइप का. सो ब्यूटेसिन पिक्रेट यानी इसमें दोनों का कॉम्प्लेक्स होगा, ब्यूटेसिन का और पिक्रिक एसिड का. पिक्रिक एसिड इज एंटीसेप्टिक एंड ब्यूटेसिन इज एनेस्थेटिक. ओके, तो इन दोनों का कॉम्बिनेशन is given as 1% ointment. Okay, so this is another application of this. Then next one, we have inclusion complexes. So under inclusion complexes, we have clathrates. So example over here is hydroquinone for krypton 85. तो जब भी क्रिस्टलाइजेशन होता है तब हमें इस केज की जैसे एक स्ट्रक्चर मिलता है. ओके, सो दिस केज हैज some holes, okay, that can accommodate some molecules. Okay, they can trap some molecules in this cage. Okay, this is an example of it. Then we have channel lattice type. In this we have example as starch and iodine. Okay, in this what happens, ये जो iodine है वो ग्लूकोज के molecules में trap हो जाता है. Okay, then another example is methyl alpha lipoid with urea. Next है layer type. इसमें example है clays. Okay, in this clays the hydrocarbons, alcohols, glycols get entrapped into this clays. Okay, then we have monomolecular type. उसमें example है cyclodextrin. Okay, this is very important. So cyclodextrin जो है, this is a structure of it. So we can see here that this is a host molecule which is a beta cyclodextrin. This is there is a hydrophilic entrance and hydrophobic interior part, and whatever cavity is there inside is for guest molecule. Okay, and there are different types of cyclodextrin: alpha, beta, and gamma. Okay, and accordingly they will have 6, 7, and 8 units. And this beta and gamma cyclodextrins are very much of importance in pharmaceutical industry. Okay, and last one we are having macromolecular type. In that we have zeolites and silica gels. Okay, so now next question. Determine the correctness or otherwise of the following statement. P statement: rheopexy is the phenomenon when a sole forms gel more readily when sheared gently. Okay, then we have Q statement as in a rheopectic system, sole is in the equilibrium form. And we have R statement as rheopexy is the phenomenon when a sole forms gel when the material is kept at rest. Okay, so this was a question from GPAT 2011. And first we'll see the definition of rheopexy. Rheopexy is the phenomenon when a sole forms gel more readily when sheared gently. Okay, so first it will be in form of sole, then it will, when it will be sheared, it will get transformed into gel. Okay, and again sole when kept at rest. Okay, so more readily when sheared gently. So the first statement we can see here is that rheopexy is the phenomenon when a sole forms gel more readily when sheared gently. So this statement is absolutely correct, right? Then next statement hai, in a rheopectic system, sole is in the equilibrium form. Okay, this statement will see here, gel forms sole when kept at rest. Okay, so the first one is in the sole form. When it is sheared, it will get transformed into gel and then again sole. So the equilibrium step over here is gel, but in this statement it is given Sol is the equilibrium state. So this statement will be wrong, correct? Last statement hai, rheopexy is the phenomenon when a sol forms gel when the material is kept at rest. This is also wrong. Why? Because here it is given gel forms sol when it is kept at rest, right? And this behavior, rheopexy, is opposite to the thixotropic behavior. The examples are gypsum paste, lubricants, okay, etc. So next we'll see the thixotropy fluids. So thixotropy fluids show a decrease in viscosity, okay? There will be decrease in viscosity with time when it is subjected to constant shear rates, okay? यहाँ पर जो viscosity होगी वो कम हो जाएगी when we apply a constant shear rates. An example over here is thixotropic material showing bulge in the hysteresis loop is aqueous bentonite, okay? So this is one example. And so correct option here over here will be B, that is P statement is true, right? This is true, but Q and R are false. Next, these are the types of fluids and examples, okay? So under Newtonian fluids, these follow Newtonian's law, that is examples are water, solutions of syrups, okay? And this graph you can see, this is a linear graph for Newtonian flow, okay? Shear rate of shear versus shear stress, okay? Slope is fluidity over here. Then we have non-Newtonian fluids. Under that we have heterogeneous dispersion such as emulsions, suspensions, etc. Okay. Under that we have first one as a plastic flow. Under that examples are flocculated particles in concentrated suspensions, certain ointments, pastes, and gels. Okay. And here we can see in case of plastic flow, they are not starting from origin. Okay, जो graph है वो origin से start नहीं होता. Okay, it starts when it exceeds the yield value. Okay, so yield value क्या है? It is a force which is required to break down the interactions between the particles. Okay, जब interactions break down होते हैं तभी वो फिर वो Newtonian law follow करता है. Okay, then it becomes linear. Okay, and slope over here is mobility. The next one is pseudoplastic flow. Under that, we have natural and synthetic gums, polymer dispersions such as tragacanth in water, sodium alginate in water, etc. Okay, and pseudoplastic flow is also called as shear thinning systems. Okay, and here we can see the graph of pseudoplastic flow. Okay, it is not linear graph. Next, we have dilatant flow. In this case, examples are suspension of starch in water, suspension containing high concentration of solids, more than 50% of small deflocculated particles. Okay. And in dilatant flow, these are called as shear thickening systems. Okay. And the graph we can see over here, which is also not a linear one. Now, there are a few more questions remaining, but if you want more such videos, you can subscribe to our channel, Dharmesh Mehta GPAT. You can press the bell icon and you will be notified every time a video is posted. And if you want to get add on our WhatsApp group or if you want to get enrolled for the classes, you can contact these numbers. Okay, you can mention your name, your college name, and we will do the needful. Next question. What will be the time required for a drug exhibiting first order rate constant of 4.6 per hour to be degraded from initial concentration of 100 mg per ml to 10 mg per ml? Okay, and this was a question from GPAT 2011. Okay, now in this question we are given the first order rate reaction. Okay, so what is first order rate reaction? For first order reaction, the rate of reaction is directly proportional to the concentration of reactant. Okay, but the rate constant of first order reaction is independent of the concentration units. Okay, this will get a better idea when we'll see the units of this first order reaction. Okay, so this is solution for this question. So first, minus dc by dt is equal to k1c. Okay, this is a representation of rate of reaction of first order. जब हम इंटीग्रेशन करेंगे तब हमें ये फॉर्मूला मिलेगा, k1 is equal to 2.303 t log of c0 by ct. Okay, and this also we can write as k1 is equal to 2.303 by t log of A divided by A minus X. Okay. So here A is nothing but C naught and X is nothing but the concentration of reactant consumed during time t. Okay. So A minus X is CT. Then in questions we are given the K. K is what? 4.6 per hour, that is the rate constant. फिर हमें A दिया है as a 100 mg per ml and A minus X is given, that is CT is given 10 mg. So by solving we are getting the answer 0.5 R. Okay. Then these are so the correct answer is 0.5 R. So summary, this is the summary of the kinetics of zero order, first order and second order reactions. Okay. So this is a representation of rate law and this is a concentration time equation. For zero order, we are having concentration of A is equal to initial concentration of A minus KT and half-life as initial concentration of A divided by 2K. Then we have for first order, ln concentration of A is equal to ln initial concentration of A minus KT and T half as ln 2 by K. Then we have for second order, 1 by concentration of A is equal to 1 by initial concentration of A plus KT and T half as 1 divided by K into initial concentration of A. Okay. And these are the units. So zero order reaction have rate constant units as moles per liter per second. Okay. First order reaction has units per second. Okay. So now this statement is clear. जो हमने यहाँ पर पढ़ा था कि rate constant is in case of first order is independent of the concentration units. Okay. So here we can see they are not having concentration units. They are just having the time units. It is per second. Then for second order reaction, it is per mole liter per second. Okay. Now next question. Granule density is determined by. Okay. So the granule density is determined by helium pycnometer, mercury displacement method, both A and B, and none of the above. Okay. So this was a question from GPAT 2011. Okay. And first we'll see the different terms which are involved. So true volume is nothing but a volume of powder itself. Okay. यहाँ पर पूरे powder का volume आएगा, excluding the voids or the pores which are present. Okay. Then we have granule volume, that is the volume of powder itself plus the intra-particle space or a pore. Okay. जो दो particles के बीच में जो space है within a particle, okay, within a granule, the granules are made up of small particles only, right? So these different particles, the gap which is present between these particles, okay, so this intraparticular space is considered in granule volume. Okay. Then last one we have bulk volume. In this we are considering the volume of the powder plus the volume of intraparticle जो हमने यहाँ पर granule volume में देखा था, plus the volume of interparticle, मतलब दो granules या दो different particles के बीच में जो space होगा वो. Okay, that is a void. Now these are the types of densities and the methods which are used to find these densities. True density by helium pycnometer. Okay, and here the this is for porous solids. Liquid displacement is for non-porous solids. Then we have granule density. This is measured by mercury displacement method. Okay, and then we have bulk density, graduating cylinder method based on tapping the powder from 1 inch height thrice in 2-minute interval. Okay, so the correct answer over here is mercury displacement method. Okay, next question. Which of the following act as a non-ionic emulsifying agent? Triethanolamine oleate, polyoxyethylene sorbitan monoleate, N-cetyl N-ethyl morpholinium ethosulfate, and dioctyl sulfosuccinate. Okay, this was a question from GPAT 2011. So this triethanolamine oleate is an anionic surfactant. Then this N-cetyl N-ethyl morpholinium ethosulfate is a cationic surfactant. Okay. This dioctyl sulfosuccinate is also an anionic surfactant. And we can see here that polyoxyethylene sorbitan monooleate is a non-ionic surfactant. Okay, since it is a oleate, it is twin 80. Okay, so the correct option over here is polyoxyethylene sorbitan monooleate. So polysorbate means twins and polysorbate ester means pen. Twin are polyoxyethylene derivatives of sorbitan esters. Okay. Now there is one term bridge. Okay, bridge is polyoxyethylene lauryl ether and mirch is polyoxyethylene monostearate. Okay, that's it for today. Thank you so much. All the best for your exams.